Here is the Ready, Set, Go for Lesson 7. What comes next? What comes later? Classroom edition. Okay, 1 through 4, you're going to find the common ratio for each geometric sequence. That means you're going to take any number in the sequence except the first one, divide it by the one that came before. Pause the video when you've done 1 through 4. Sorry, that doesn't make sense. Pause the video, then do 1 through 4. Unpause it when you're done, and I'll show you the answers. Okay, so the common ratio for number 1, many of you could figure out that it's 2. But, you can take a number and divide it by the one that came before, and it's 2. Any of these is going to give you 2. Number 2, 15 divided by 5 is 3, and so is 45 divided by 5. So the ratio is 3. 3 is going to be a negative number. It's going to be negative 2. That's why this ratio, or that's why the terms are alternating between negative and positive. Right? Did you notice that? Negative, positive, as you go along. So the ratio here is negative 2. And finally, number 4 is a decreasing type of sequence. It's getting smaller and smaller. So 10 divided by 40, that's 0.25. And so is 2.5 divided by 10, also 0.25. Now let's jump into the set. Fill in the blanks for each table and identify the type of sequence. So a lot like we did yesterday. Then write the recursive and explicit equation for each sequence. So you're going to fill in the blanks. What type is it? Is it arithmetic? Is it geometric? The recursive form, remember to start with the first term and say what that is. And then write your f of n, some number plus or times f of n minus 1. And then the explicit form. All these are on the golden paper. Do 5, 6, 7, 8, and then we'll come back and we'll do 9. So do up to number 8 or as far as you can go, and then unpause the video. So pause the video now. Okay, coming back, our missing numbers. This, is, by the way, was arithmetic because you are adding 3. Add 3, add 3. So 24, add 3, 27. The recursive is that it starts at 115. We are adding 3. The explicit would be f of n is the first number 15 plus the common difference, which is 3, times n minus 1. Okay, our next one, number 6. You're going down by 4. Every time, that would be, again, arithmetic. Its recursive form would start at f of 1 is negative 2, and f of n is f of n minus 1 minus 4. And the explicit form would be f of n starts at negative 2, go down by 4 with an n minus 1. Okay, this one goes from 3 to 9. That's a jump of 6. But then it goes 9 to 27, which is a jump of 18. Your jumps are not the same. So it's probably geometric. Let's verify. Take 9 divided by 3, you get 3. Take 27 divided by 9, you get 3. Okay, so then 27 times 3, this will be 81. And then, let's see, 81 times 3. I think that's 243. So this is geometric. If this is getting easy, that's great. Should be getting easier. If this is still hard, keep working at it. It's the same thing every time. F of 1, where are we starting? We're starting at 3. And then f of n equals, now we're going to multiply 3 times the previous. The explicit form is we're going to start at 3. We're going to multiply by 3 and take it to the n minus 1 power. And let's see, number 8, I think. Yeah. This one's decreasing. Let's see, from 48 to 12, that's more than 12 to 3, so it's probably geometric. Let's check. 48 divided by 12 is 4. Yep. And 12 divided by 3 is also 4. So this is going down by a quarter each time. I'm sorry, I did that upside down, didn't I? That's 12 divided by 48. And we should be writing a quarter. So cross that out. And 3 divided by 12 is a quarter. So 0.25. So 3 times a quarter, 3 quarters. That's 0.75. And I don't know this one off the top of my head. Let's ask Siri. What's 0.75 times 0.25? And Siri's quiet right now, but she says the answer is 0.1875. So, geometric, right? Recursive starts at 48. And we multiply each term by the previous, let's see, 0.25 times the previous. Or not x minus 1, n minus 1. X minus 1, that maybe is for a future time. And explicitly, we're going to start at 48. We're going to multiply by 0.25 and take it to the n minus 1. Because we are starting at 1. Okay, now it's time to do the next group here. So notice the directions. You're going to add 2 more points to the graph that fit with the sequence. In other words, that follow the pattern. Identify the type. And then write the recursive and explicit. Now you might be thinking, well, wait a minute. How am I going to figure out with just dots the numbers I need to use? Well, remember, you can always convert the dots to numbers. This is the 0.19. This is the 0.27. This is the 0.35. And in a table, that looks like this. 192735. So really, it is just like the ones we've done before. And let's take a little peek here at the next one, number 10. So same thing. You notice this is not forming a straight line. In fact, what's happening is this is at a half, and then this is at 1, and this is at 2. So, little hint, they are doubling every time. And again, you could make a table. You could analyze it with the table. And then we'll get to the go. So do up to problem number 10. So do 9 and 10. And then unpause the video. So pause the video now. Okay, welcome back. And let's see here. So this is arithmetic. They tend to be straight lines. And let's see. So the recursive, it starts at 9. So f of 1 is 9. And let's see. F of n would be the previous. Did you notice it's going down by 2? And you could also say that that's the slope. To go down by 2 and over 1. To go down by 2 and over 1. So minus 2 every time. The explicit is that f of n is beginning at 9. And then we're going to go down by 2, n minus 1 times. So there's your number 9. And number 10 is, we are starting at 1/2. Let's do this as a quick little table over here. We're starting at 1 is at 1/2. 2 is at 1. And 3 is at 2. We are doubling as we go down. Times 2, times 2, times 2. This is geometric. And in the recursive form, f of 1 is 1/2. F of n is, let's see, 2 times the previous. And the explicit would be f of n is the beginning number, 1/2, the common ratio, 2, and the power, n minus 1, since we did start at 1. Doing good so far? Let's check out the go. Write the recursive and explicit functions for each arithmetic sequence for problems 11 through 15, then graph each sequence. Make sure you, this is your responsibility, you clearly label the axes of a recursive and explicit, and then let's graph. So 11, 12, very similar, 13. Again, we're talking money. We did a problem like this just a few days ago. Check earlier in your book if you forgot. And let's see, 14. Do something nice for 2 strangers. What's the relationship between the total number of people helped and days? So total number of people helped. Might be helpful if you made a table of this one. And then finally, a picture again. We've done this picture many times in this unit. I think the first time I did it, I said, look at these 6. And then here's the 6 got doubled. And then you could almost change color and go, well, that got, let's see. Well, did that get doubled? No, actually. I changed my mind. So maybe it's not what I thought. Maybe it's not geometric. Maybe it's arithmetic. Try that. Figure out what you're adding each time. And a graph for that. And then that's it. Then you'd be done. Okay, one last time. Pause the video and try as much as you can before you get stuck on 11 through the end. And then unpause it and we'll go over the rest of these problems. Okay, you're back. So did you notice that this is arithmetic and it's going up by 2? And so that would make the recursive f of 1 is 2 and f of n is the previous plus 2. Explicitly, that would be f of n equals the first number plus the common ratio times n minus 1. Now for the graph. I don't have to go right to the edge. I can just go like this and like this. And let me change colors here. So on the x-axis, I don't have to use every single square. I could go like, those two could be 1, and then there's 2, 3, 4, 5. You can spread it out a little bit. And then on going up, I could do 2, 4, 6, 8. Again, I don't have to label every single graph or every single box. And then just translate. So the first number is 2. The second number is 4. The third number is 6. Let's see, 3, 6. And the fourth number is 8. And I could continue the pattern if I wanted to. Notice again, if it's arithmetic, the dots will form a straight line. This one is this arithmetic? Sure, plus 3, plus 3, plus 3. So the recursive is, I take the previous and I add 3. Explicitly, I start at 3 and I add 3 n minus 1 times the graph. Again, I'm going to space this out a little bit. Since I only have to get up to 4, I'll go 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6. But I'm going to label those as 2, 4, 6, 8, 10, and 12. Now for my dots. 1 is 3. See, right in between 4 and 2 would be 3. 2 is 6. 3 is 9. 4 is 12. And sure enough, forms a straight line, doesn't it? All right, let's do this fun one. Claire has $300 in an account. That's her beginning or initial value. She decides she's going to take out. So she's taking out, that's a negative number, 25 each month. So recursively, I'm going to start with f of 1 is 300. What do I do to the previous? Well, you take out 25. You subtract 25 from the previous. So explicitly, I'm going to start at 300 and take out 2 every time, except the first month, because I'm starting at 1. Now for my graph. So we've got, now this time I have to get up to 300, and then I'll be going down from there. So how about I do every 4 squares is 100 going this way. So 100, 200, 300, 1, 2, 3, 4. Whatever makes it convenient for me, that's what I'm going to do. And then I'll just go 1, 2, 3, 4, 5. Let's see how far down I can get. So the first month, I'm at 300. That would be, let's see, let's label these. 1, 2, 3, 4, 5, 6, 7. First month, I'm at 300. Then I take away 25. So I'm here, right there. Then on 3, I take away 25 again. By the time I've done 4 months, I've lost, or she's taken out. Let's see, did I line that up correctly? 1, 2, 3. Did I line it up correctly? Yeah, this one is going to be down 1, 2, 3. Yeah, okay, that was right. And then right there. So by the time I count to 5, now it's gone down 100 because I've gone down 4 steps. And then just keep going like that pattern. And there we go. It's definitely arithmetic, isn't it? Straight line. And then finally, each day Tanya decides to do something nice for 2 strangers. What's the relationship between the total number of people she helped and days? So again, you might want to set up a little table when you're doing these. On the first day, she helps 2 people. And then the second day, she's helped 2 people and she helps 2 more. So she's helped 4. On the third day, she's helped a total of 6 people, and so on. So as you can see, the common difference is 2, and you're starting at 2. So this is definitely arithmetic. F of 1 is 2. F of 1 is 2. And f of n is f of n minus 1 plus 2. Explicitly, that would be f of n equals start at 2, go up by 2 times n minus 1. For a graph, I can basically do what I did before. On the x, I can go every 2 squares is 1. There's 1, 2, 3, 4, 5. It doesn't say how far I should go on this. And I can do the same kind of scale going up. 2, 4, 6, 8, 10, 12. We're just trying to get an idea of what the graph looks like. Let's see, this would be 10, 12, and 1, 2, 3, 2, 3, 4, 5, 6. So I do have different scales on my x and y. Let's see, on the first day, she helps 2 people. On the second day, she's helped a total of 4. By the third day, she's helped a total of 6. And it just keeps going up and up and up, just like that. Okay, I think that's the last one, right? Nope, one more. On the last one, I thought it was geometric, but it's actually arithmetic. You keep adding 6. You add a group of 6 every time. You start at 6 and you add 6. So f of 1 is 6. And what I do is I take the previous and I add 6. Explicitly, I start at 6 and I add 6 n minus 1 times. And for my graph, this is going to have a very steep graph on it. I messed up. The iPad version doesn't have a ruler. On the Windows version, it does. So maybe one of these days they'll put a ruler in this thing. Okay, so 1, 2, 3, 4, 5, 6. And let's see, how about vertically if I go every 2 is 3? How about if I go 3, 6, 9, 12, 15, 18. So 3, 6, 9, 12, 15, 18. And this will just go 1, 2, 3, 4, 5, 6. 1, I have 6. In figure 2, I have 12. And in figure 3, I have 18. So definitely straight line, definitely it's arithmetic. All right, that's the end. Don't forget to turn in your assignment when you're done.
Dream big, right? So, what I want you to do is dream the biggest that you can. And then double it.